So 10 years after that, a new era for NVIDIA came into existence. On top of CUDA, the whole deep learning AI revolution was born. The first thing that sparked this was at the University of Toronto. Some grad students, Alex Kraszewski and Jeff Hinton's group, they took an old idea, neural networks, a bunch of new data that was now available because of the internet, and combined it with essentially a supercomputer that was in their gaming system on a gaming GPU, and were able to do things that had previously eluded computer scientists. We up until that point, we had no way of creating an algorithm that could reliably tell the difference between a cat and a dog in images. And so overnight, that changed everything. Now we could write software that writes software. And when that happened, everything kind of changed. We realized that the way software is going to be created, the most advanced software, software that simulates intelligence, is fundamentally different than how all of the software we've created before has been created. In order to create this new software, these new algorithms, you need an immense amount of data, and this data has to be very specific, and it has to, in most cases, match the real world. We need algorithms that give these robots intelligence to understand the world around them. They're going to see that world, they're going to perceive. And in order to do that, to create those algorithms, we have to feed the training mechanism, the way we create it, with data, which is another way of saying we're going to feed it with life experience. We need to create simulations of these virtual worlds so that we can have these new intelligences we're creating be born and raised inside these virtual worlds. And it turns out all of the accelerated computing we've been doing all these years have all the ingredients for the things we need to construct the worlds: rendering, physics simulation, and the new AIs we're creating to populate those virtual worlds to begin with, or help us build it. And so Omniverse basically came from that. We started building the computing stacks for self-driving cars, for robotics, and essentially digital twins of the advanced things we're trying to build internally here. And we always try to use all of the tools, everything that's already available out there before we create something new. But when we see that there's a gap, that there's something that's missing that we need and nobody else is building it, then we go build that thing. But we try to bias towards connecting to all of the things that already exist there, so we don't have to duplicate effort. So you see this with Omniverse. Omniverse it's kind of two things. First, it's a system for aggregating or connecting all of the tools and data sources you might have for building virtual worlds. We built it around USD, Pixar's USD open description of virtual worlds, so that we could not avoid having to build all the tools we might need to construct these worlds. We want to collect them all together, and then we've built a specialized computing stack for doing these kinds of simulations, designed to scale from relatively powerful computers like our NVIDIA workstations, up to supercomputers that have many GPUs and many nodes, so that you don't have to make a trade-off between accuracy and fidelity of your physics and world simulation and speed. That's kind of like the two sides of it. But in many cases, we choose, or we need to run simulations in different simulators. So just having the world all aggregated into this form, it's an open description, allows us to use any simulator or engine out there potentially for the particular problem at hand.